So now in this video we have 12 volts powering this circuit. This is an LED being protected by one resistor that's rated for a quarter watt. So we kind of need a 1000 ohm resistor or higher, otherwise the resistor will get too hot. But that's limiting current. We have the 2 volt drop of the LED leaving about 10 volts across the resistor for about 10 milliamps of current. You can see we got probably a little bit less right there. We have a simple solution. My goal is to get closer to 15 milliamps of current. So with the 1000 ohm resistor giving us 10 milliamps of current, a 2000 ohms, this is actually 2200, but a 2000 ohm resistor would give us 5 milliamps of current. We can simply add those currents together by putting this, it's actually 2200, but a 2000 ohm resistor in parallel right there. So now you can see that the currents added up. We got about 5 more milliamps. We're probably just kind of borderline 14 milliamps. It's probably just slightly lower. So now I do have a schematic diagram there. I dimmed the lights a little bit because I think it's a little easier to tell now that when we remove that resistor, the LED is less bright, and when we add it, it is a, there we go, a little bit brighter. So now at the start of the video, I just used a simple process. If you have a 1000 ohm resistor protecting a red LED from 12 volts, red LEDs tend to drop about 2 volts. So you have 10 volts across the current setting resistor. 10 divided by 1000 is 10 milliamps of current. Hopefully that makes sense. So it's pretty simple. If you want half of that, so in this case we want to add half of that, but if you want to have half of that current, you use twice the resistance right there. So 10 volts divided by 2000 ohms will give you 5 milliamps of current. Putting them in parallel, they simply add together. So this one's really easy for mental math, but if you have values that aren't so easy that you come across, here is a formula intended for 2 parallel resistors. You need a different formula if there is more parallel resistors. This only works if there's 2. But you take R1 times R2, and then you divide that by R1 plus R2. Doesn't matter which one's R1 and which one is R2, as long as you stay consistent throughout the formula. But 1000 ohms times 2000 ohms is 2 million ohms, and you divide that by 1000 plus 2000 ohms for 3000 ohms right there, which you get 666.6, repeating forever. And there are 680 ohm resistors, but like I said, you're kind of at your limit when it comes to wattage with the 1000 ohm resistor. You go lower in value, it's probably going to overheat. So instead, you can just add some more current by taking an even higher value resistor and adding that extra current that you desire.